All right, guys. For this one unit, there's going to be a two-parter. For right now, we're going to be looking at networking basics. So don't worry, I will try to make this simple to understand. I know networking can get very convoluted. The terminology can get very complex very fast. If you have questions on some of the terminology about networking, please feel free to reach out to me so I can clarify some of it for you, okay? So going on to the next slide here. And as I stated, this is what we'll be covering in this unit. There will be another part of unit one that will be dealing with the server. And that will be after this lecture. It should be up now. If not, let me know. So, what are we going to be covering in this lecture? We're going to be looking at why do we network? What's an IP address? What's a MAC address? Something called the OSI model. We're also looking at something that's called ports. They are both physical and digital ports. I will explain more of that when we get there. Something else called TCP and IP. You may have heard of those before. If not, it's okay. We will also talk about that. Then we'll talk about IPv4. There's another version thing called IPv6 that I won't really need to touch on because it can get very complex very fast if I bring that up, and I don't want to overwhelm you guys. Personally, I feel like I'm going to be overwhelming you with all of these topics, but this is more background information that you're going to need in order to make your server successful and so it will function properly. And the last thing I'll cover are types of networking topologies. All right, so why do we network? What's the point of hooking up your home computer to a network? You want to reach information. You want to be able to go to Google. You want to be able to go to watch Netflix, for example, Disney Plus. Mandalorian's out in March, by the way, if you're curious. That's the reason we essentially network is to get from one place to another. For example, in this diagram that I have right here, you see that this computer with that line is hardwired to something called a router. The router also does what's called wireless, hence how the printer is hooked up. So let's say you found these pictures of cute cats that you want to print. And instead of it being wired, you would send a print request to the printer wirelessly over the network. It's essentially just a matter of sharing resources and getting from one place to another. So inside of a network, any machine that is connected either physically or wirelessly, such as your computer. My computer, for example, is wireless. It will have something called an IP address, and it's a string of numbers. It's going to be 192.168. Let's say 1.87. And on the network, that number identifies my machine. So whenever machine .1.68, which I believe I said were the last two digits of the whole range of numbers there, request information, it will know that is my machine. But there's also another component to it. Since my machine is wireless, the wireless card or adapter will have something that's called a MAC address, and that's a media access controller address. I know it's convoluted, but that's a unique set of identifying numbers that are specific to that piece of equipment and say that is literally the thing on the network that has this IP range translates into this. Also, we're rolling back into IP for a little bit for a second here. Think of your IP address as your computer's house address. So, for example, my address out here where I live hypothetically is 1234 King Street. My computer is 1235 King Street. So 1235 King Street needs information from the network. It requests it, it sends it, it gets it, and it receives what it requests. So if I want to go to Google, I'll send it'll send a request that, hey, 1235 King Street is requesting information to reach Google, which will be translated into its own IP address. I'm not sure what IP Google is using, but that's usually how it works. Okay. This guy here looks very intimidating, but it really isn't. And the reason I say that is I don't use this every day in work, believe it or not. This is more of something I kind of run through in my head saying if there's a network issue, where could it be? Could it be in this area, that area? And they all relate to different things. And this is called the OSI model, which stands for Open System Interconnection Model. You can think of it as a burger. I mean, who doesn't love burgers? I personally love burgers. And I will be going through each layer with giving some specific information about it. So think of layer one, we're starting from the bottom. Layer 1 at the bottom is the physical layer. This is the hardware layer where you can touch things, and some things you can't. I know it sounds kind of weird, but your Ethernet cables, your network cables live there. Bluetooth lives there. It's think of it as all the wires connecting all telephones throughout your neighborhood. Followed by layer 2. It's the data layer. This is where information from the network is broken down into frames. They're transmitted from physical to the network layer, and it's responsible for some error detection and correction. And it's what deals with addressing in sense of, hey, computer dot one dot one dot, let's say 168 wants this information to computer dot 2.168. Oh, okay, cool. Let me send it that way. Oh, wait, there's a problem sending this thing. Let me resend it. That's kind of where it works. You can think of that as the phone numbers for everyone in your neighborhood. So moving on to layer 3, the network layer works to coordinate related parts of data conversations to ensure that larger files are transferred. In other words, well, the data link layer deals with method in which the physical layer is used to transfer data. The network layer deals with organizing the data for transfers and reassembly. The layer also handles aspects of routing protocols, finding the best available path from one network to another to ensure that delivery of the data. So within the network, it goes through a bunch of little hoops and loops, and they all have a kind of a cost associated with them. So if it costs you to go through 3 loops and total toll for those 3 loops is 12, it means each jump is 6 hops or 6 bits of data, if you want to look at it that way. Well, we use bits rather, but 6 increments of power. So first one's 6, next one's 6 more, so that's 12, next one's 6, so that's 18, versus this one's 4 hops, but each of them is 3, it's going to cost 12 because the first one's 3, second one's 3, you add it, that's 6, next one's 3, that's 9, next one's 3, that's 12. Those 4 hops are cheaper to take than those first 3 hops. It will do the 4 hops that are becoming cheaper. You can think of this as the address book your mom has with your neighbors' names and numbers in it. So know where to route things and where to send things if they're big enough files. And then moving on to the transport layer, which is layer 4, where currently right here. The transfer layer is responsible for logistics of the server, or the session, I'm sorry. This layer manages traffic flow through the network layer to reduce congestion on the network and perform error checking, ensuing quality of service for sending data when data has been corrupted. So transport layer essentially handles everything that's been sent all over the place. So you're sending a request to the printer. Okay, cool. Send that to the printer. Then, oh, okay, you're requesting this for Google. Let me send that to your router, which will send it out. Then it's kind of like a postmaster, or if you want to look at it, it's more along the lines of a telephone company. Telephone company, you make a call 911, it routes you to 911. You make a phone call, I don't know, to your baker. So you like eating Coco's pie, for example. You punch in the number 1-800 Coco's pies, let's say, and that links you to Coco's. That's where they connect you to. That's how the transport layer works. So moving on to session, layer 5. Sorry, throat's looking dry. This is the session layer. The session layer is launched with authentication, and the request is then issued. The session can stop, or a new request might be sent following a response. This client server idea is first introduced in this tier. An individual device may switch from playing the client to a server or vice versa. So what that means essentially is that, hey, I'm computer 1. I want to request items from computer 2. And once I'm done, I'm going to hang up. But then computer 2 can request the same information back from me, computer 1, where I would become the client at that point. So from the beginning, I'm the client connected to the server. Then where computer 2 can switch and be like, okay, we're done. Let me connect back computer 1. So now they become the server and I get back information to computer 2. Think of this as the telephone company's equipment that makes the phone ring when someone calls and ends the call when it hangs up the phone. That's the best way you can think of layer 5. Then layer 6, the presentation layer. This is where all the data go from zeros and ones, bits and pieces, like everything on your screen. If you've seen this old movie called The Matrix, they showed it where it's all this text coming down as zeros, ones, glyphs, and all that jazz. That's essentially kind of what gets sent all over a network. And what the presentation layer does is it takes all that and translates it to something live. So when you type in www.google.com, it pulls up the Google webpage, right? The first thing you see is Google, then you see the search bar. Well, all that's zeros and ones. What the presentation layer does, it converts those zeros and ones and converts it into something you can physically see on the screen that you can read. Because if it was all zeros and ones, I mean, that would be pretty difficult to read, wouldn't it? You can think of this as the telephone in your house. So layer 7, the application layer. This is actually where you physically see in terms of loading an application. So when you go to Chrome, Edge, Firefox, even your mail applications, this is where all of this lives. So you can think of this as the microphone and speaker on the telephone lets you hear other person when they're speaking. All right, moving on here. Let's talk about ports. What's a port? You know, where ships go to dock? No, there are two kinds of ports. There is a physical port, like the one they have pictured here, that you use this guy. You plug into there, and you are now connected to the network. Congratulations. And then there are virtual ports, which are pretty extensive. There's a list of them here on the next slide. Let me swap over. And you can see there's a big amount of them here, huh? There's